Alright, so in today's episode, we are going to analyze, prepare data, and learn from the data with Matlab, correct?
Exactly, and we are going to do it with a very, very basic, because we talked about AI a lot. Now we just imagine we have a data set, and we want to try to analyze the data set with Matlab, like really basic steps. So what's the data set about?
The data set is about different trips, different driving trips. So basically, each of them is someone driving an electric vehicle, driving from A to B, and we have different kind of data from the distance to the consumed battery in percent. We have the consumed battery in kWh. Do you call it like that? kWh? In what?
Kilowatt hours.
Kilowatt hours, exactly. And also some other data from the speed, such as the maximum speed, the minimum, the average, and many other things, as we can already see here.
Yeah, exactly. So what we did is, just to give you a little hands-on, we just moved the data that we got from the database into our workspace. Pretty easy. This is still a CSV file. Then we just double-clicked on the CSV file, and then Matlab opens an import manager, something like that. And here we can, which I think is very important, name the data. So we know, like now we have all the variables. It already detected them as such, so we don't have to do that anymore. But we see here in line 1, here we have the names. So Matlab already took the name as the variable, so that worked as well. This one, we don't have anything, so we call it ID. So this is one trip, right? So we measured the temperature, outside temperature, and other parameters of car drives, and we now try to estimate something. Okay, so anything else is right. Next step that we do is we just import the selection. Well, import the selection, then you have to select everything. Otherwise you won't import anything. So now we just import the selection, and it's pretty much done already. So driving data is now here available.
But we had the first row is basically was actually just the column titles, right? That was my question. Can we just delete it? Yes.
It's just go.
Question answer.
You can do it more professional with a command line though, but we try to do it as simple as possible today. So now we have to think about the problem. What kind of problem is this? Is it a classification problem, or is it a regression problem? So the difference between classification and regression is very simple. Can you explain it?
Basically, in classification problems, you have, as the name suggests, different classes. You want to predict. That's basically the goal.
Just give an example.
For example, you have a picture and you want to say whether it is a dog or a cat.
Exactly.
And that's basically classification problem. Other problems would be if you put you give a text as an input, and you have maybe different classes of type of character of person. You basically be creative. There are different kind of classes.
Exactly.
Right.
Yeah. You
and
can.
On the other hand.
Yeah. You put the data, and give it a class and say, well, this is a mean person. This is a blue picture. This is a cat. This is a fast driver. So what's important is there is no such thing as a classification problem, like per se. I don't know if that's possible to say that in English, but you can formulate each problem into a regression problem, and you can formulate each problem, but not all of them, but most of them, into a classification. Let's take an example. For example, you can take a data set where you have pictures of people, and you classify them into woman and man. Or let's take the height into small, medium size, or tall. Or you can go and make it less granular, so more fine, and say, well, it is like really small, then medium small, small, a little bit taller, and so on and so forth. So if you go down, you can end up somewhere where you can just say it's from 0 to
Yeah.
10.
So the definition is basically based on our own classification, right? So each row have to have some kind of class on it already labeled before you start the machine,
no,
machine learning.
No, I'm just, so we are step 0 right now. We're just deciding, is it a classification problem or is it a regression problem?
I see.
And my point was, if you take, for example, a problem that is basically a regression problem. Let's take a regression problem. We want to estimate a temperature. So this is a number which is continuous. So it's basically, it's not hot or cold. It's 28 degrees Celsius. So it's a number, and it can be 28.1 or 28. So it's continuous. But we could formulate this as a classification problem by defining the class 21 degree 0.1, and so on and so forth. So if you have like many classes, you can take a problem that's actually a regression problem. That's also how we use models that are made for classification actually in regression models. However, so we can decide now, is it a regression problem or a classification problem? So what do we want to estimate?
So in this case, I think a very interesting part of it is the energy consumption.
Energy consumption.
Exactly. So that's how much the vehicle has consumed or verbrauch.
Yeah, consumed. That's correct.
During that specific trip.
Awesome. Yeah, let's do that. So we are going to do it with a regression. And this is going to be very, very good. We are going to have very good results. So we go here to the apps section. We can do it in code, but we will do it in the apps section today because it's easier. Here we choose regression learner. We have other different types of apps which we can use, but right now, by the way, if we would have stated that this is a classification problem, then we could have used that one. But we go on regression learner, then the app opens, hopefully fast, so we don't have to wait. But the data set is pretty okay, so it should be up pretty fast. So here we go. Now that we have the data set in the workspace, now we open up a new session, and now we have the most important part. I don't understand why it's cut. It was cut like 10 minutes before as well. Anyhow, we will use it this way. Okay. So workaround, just resize the window. Now that's very important. We have the set of variables, which is defined here. I hope the mouse is, we can see the mouse. Then we have the response. So what do you want to predict? We said you want to predict the energy consumption. This is why I said we have to name it, because right now we just can't see the name of the variable. You can scroll. Do you see energy consumption?
Not yet, actually.
It's consumption. Right?
Energy consumption, there it is.
Oh, yeah.
But somehow, I think there is something wrong with the data, because the energy consumption is minus 31.374.
Yeah.
You know, I think we had some really
outliers,
bad,
right? Yeah.
Or bad computation.
Let's see what happens if we don't clean up the data. All right, so we go here, and what you see is in the line of predictors, automatically energy consumption is not selected anymore. You can't select it because it doesn't make sense to give the model the predictor that you want to predict. Okay, so it's gone. So we remove all because there are really many, and we just want to select some. We can add all and see which ones are the very important ones, but for now we just think about, we now apply domain knowledge. What is a powerful predictor for the energy consumption? I would say odometer start and odometer end. And battery level start and end. I wouldn't say that this is very important, so leave it away. We just use these two. Is that fine with you?
That's probably already the most important. We can add more, such as the temperature, the speed, but we can also just start with this if you think that's
I think
sufficient.
this is going to be very fast. So we just start the session. And what happens now is we get a draft and Matlab just prepares the data. And we have some other, now we see the data. So we have the number of measuring points and the different responses we got.
These data here.
These
down
are
below,
outliers, yeah.
right? Yeah.
So you can directly see where your outliers are. And it's pretty easy to delete them. So you can just find for negative values and just delete them. So now we can select what kind of model we want to use for the prediction.
Regression trees, interesting.
What we can do is this. I really love this function. You can go for all or all quick to train. We go for all quick to train. So now it just takes all the models that are quick to train. We don't use PCA. PCA is the principal component analysis we talked about last time. So where you can see which components are really important for the results, for a good prediction result. All right, so just leave it like this for now. We use parallel since we have a little bit more computation power here. I hope it works. Didn't test it in this setup. Jen, just play, press play, I think.
This is actually really easy to do compared to Python.
That's what I said.
In Python, you really need to type everything down.
You can use Matlab in this way as well.
Okay, I see.
So if you want to get more sophisticated, or if you want to have neural networks, then you need to have.
Oh, in neural networks, you have to type everything down. It's
well, no, we have simple neural networks here as well, but yeah, for more sophisticated ones, you will need that. So here we see the first results. So we have linear regression. We have trees, decision trees. And these are just 3 types of decision trees: fine, medium, and coarse trees. And we see the root mean square error for the validation data, which we also show you how to set it, is around 6. So now the question is, what was the dimension of the consumption? 6 kilowatt hours. So if this is the error, we can see here, this is very bad. This is very poor system behavior. So what we can see now is linear regression or decision trees seem not to be suited for this kind of parameter set and model. So we go here and press all, and now we should have another one here, and just train it again and use parallel.
I think the outliers are like the biggest problem here, because I actually met similar results when I just trained them, just without cleaning at all. Because as you can see here, right here, like what is this one like up there? What is that one doing?
But hold on, this is the prediction, right? This is the prediction. So this is where it actually was, and this is how we predicted.
This is where it was? I thought it was actually the other way around, because the dots, they look like the real data. Are they not? True response?
Well, here you can predicted versus actual validation data. Honestly,
hey, look at this observation.
Yeah, observations.
Prediction.
But yeah, usually it is 2 colors. One is blue, one is orange. Something is wrong here. However, right now all the other models are training. Now we have here ensemble of bagged trees, which has a better RMSE, which is still really crap.
What is the RMSE actually saying?
Root mean square error. That means that how far away are your predictions in like the mean value of the error of your predictions and the root square of it.
If it's saying like 6.1, does it mean that my accuracy is at 94%? Or
No, no, no.
no.
No, it says that your average prediction is 6.16 kilowatt hours away from what actually is.
Oh, actually,
Yeah.
that's actually not good.
No, it's not. All right. So now you see, for example, the GPR is failed. It didn't even manage to train it, and all the others. But this one, for example, the neural networks looks a little better. We have outlier still, but it's looks more aligned to this curve. Our perfect prediction would be here, so that would be very good. And actually here, this is the plot. So this is the true is shown in blue, and our prediction is shown in yellow. I can also show the errors. It's very hard. So see, now you see really how it performs. And also, this is a very important point. The physical system can't have negative energy consumption. Maybe this is because the guy charged his car or something happened. We don't know. But if you put data into the data set that contradicts the actual nature of the problem, you mess up the whole system. So you have to be very careful about that. All right, here we have another one. So we have tested this. So let's see what happens if we now want to add. See, this is even better. This is better. We have now 4 with the neural network, a bilayer network. The reason might be maybe that this kind of network can basically approximate any kind of data set. So even though our data set is messed up, it can approximate it. So what we can do next is basically, I think that's fine for now. What do you think?
Yeah, sure.
Support vector machines do not work at all.
No,
but
nothing.
Just to recap recap real quick. What did we do? Can you just repeat?
Basically, we did an import of our data set. This is the first step. Afterwards, we click on import selection. Then it was on the other window. And when we are here, we started the learner, where we first of all exactly say which value do we want to predict, and on the other hand, what are the features of this for this prediction. In this case, we had odometer start and odometer end, and afterwards we just had to choose which machine learning algorithms we want to basically train. Exactly, here we are.
Here we choose which data, and for now we can just like add everything. And what here we said which variable it is. Here we said which variable we want to predict. We said we want to have energy consumption, and then we can now import all of the predictors. Yeah, and that's it. Then we can choose the model.
Yeah.
Maybe one last thing, which is a little bit more sophisticated. It's not at all. It's just still very basic. But if you go, for example, we decide that maybe support vector machines are a good model to use in here. So we go here, and then on advanced, we can choose something that is very important, which is which kernel function do you want to use for that. It makes a dramatic difference which one you use. You can play around and see which one works best. Box constraint mode, don't even know what that is exactly. Epsilon mode, kernel scale mode, this one is important too. And here, this is a point where we talked what we talked about. Data if we want to use data for models, it's very important to make them somehow to normalize them. It doesn't make sense if in one data set you have one variable that goes from like 0 to 10 and the other one is like -10 to 300.
It's
and
scaling up basically, right? From 0 to 1. Is it?
Yeah,
the
that's
process?
for example, that would be a way to do that, to normalize all of them, to have the same scale. So one thing is here, and the other one for the neural networks, and here. And we can, by the way, we can just train it with all the features. Let's see what happens, because we have the previous results. So soon as it's training, we can not choose none of them anymore. And what I wanted to say is the validation data. You can choose that as well. How the validation data is used, because we wanna train a model. We take our data sample and then we split a part of the data sample away, so we can later on check if the model that we used or that we created, that we trained, just learned the data set or is generalized, so it knows how the system works. Therefore, we take a part of the data away and take the data later on and test the model and see if the results are as we expect. This is how we validate the model.
To test how it perform, right?
Exactly. So
and with how much percent are you
25%.
25%.
Yeah, and here you can even see what we do here. We do a 5-fold cross validation. You know what that is? So you can take 20%. It's 20%. So you take the data set and divide it into 5, and then you train and then validate, and then you do it again and again and again 5 times. So all right, but I think this will take too long, because we have now 27 features and the data set is not too small. And even though we are working on the GPU, I think, and in parallel, with 12 workers, it will take forever, I think. So maybe that's a good point to stop.
All right, then I guess thank you for explaining the whole.
Of course,
Matlab
next time
software.
Python.
Next time we'll start with Python, and also what would interest me next time, how would actually the model perform if we clean the data before?
Way better. I can tell you right away.
Yeah, like I would, like right now we have what
6
is it?
point something.
Yeah, that's like really bad. I mean, like.
Yeah, that's really bad, because
We
the whole battery is like 70 kilowatt hours, and if you have a 10% error right away, and the trips aren't from 100 to 0, so that's basically maybe the whole range of the data set, which is your error.
Yeah,
So that's bad.
All right, thank you, and let's see you again next time.
Of course. See you too. Okay, goodbye.